Different large denominators. For different large denominators, we're going to use prime factorization to find the least common denominator. And any changes to the denominator must be reciprocated to the numerator. And then to build up to the least common denominator, we will multiply by any missing factors. So let's look at example 1. Solve for the following. We have 5 over 21 plus 9 over 14. So what we're going to do is we're going to do the prime factorization for both 14 and 21. So 14 can be broken down into 2 and 7, and 21 can be 3 and 7. So those are the prime numbers. So when we find our least common denominator, we look at all our unique factors. So it's 2, 3, and 7. And we only have one of each, so we're only going to go ahead and multiply it by each one by 1. So we have 2 times 3, which is 6, times 7 is 42. So our least common denominator will be 42. Now, when we look at 5 over 21, we are only missing the 2. So we're going to go ahead and multiply the top and the bottom by 2. Then we're going to add 9 over 14. Now, 14, when we break it down, is 2 and 7. So we're missing the factor of 3. So we're going to multiply the top and the bottom by 3. So then, now what we're going to do is then we're going to go ahead and multiply the top together, and then we'll multiply the bottom numbers together. But our bottom number will be our least common denominator, which will be 42. So now 5 times 2 is 10, which is over 42, plus 9 times 3 is 27, which is over 42. So next, when we add the top, and we're going to keep the denominator. So our total would be over 42, so 10 plus 27, so that's 37. So our solution is 37 over 42. Now let's look at another example. Example 2, solve and reduce. We have 17 over 18 plus 3 over 20. So we need to find our least common denominator. So how we do that is we're going to break both these numbers into the prime factorization. 18 can be 2 and 9. 9 can be broken down into 3 and 3. So that's the prime numbers. Now 20 can go 2 and 10. 10 can be 2 and 5. Now let's go ahead and find our least common denominator. So we see that we have all the unique factors of 2, 3, and 5. Now we need to assign the highest exponent to each one. So we notice in our 20 we have 2 2's. So we're going to assign it 2 to the raised to the second power. Now 3, we have 2 3's in 18. So we're going to go ahead and multiply that by 2 3's. So we go 3 raised to the second power. And then we just have 1 5. So we're just going to leave as is, or we can just show it as 1 in the exponent. So when we multiply this out, so we have 2 times 2, so that's 4. 3 times 3 is 9 times 5. So now we go 4 times 9, which is 36. We're going to multiply it by 5. So 36 times 5. So 6 times 5 is 0. Carry the 3, so it's 30. 5 times 3 is 15, plus 3 is 18. So we get 180. So our least common denominator is 180. Now, if we were to break this down, 17 over 18, So that's 2 times 3 times 3. What we will do is we're going to multiply by the missing factors. So we notice that in our least common denominator, we have 2 2's. So we need to add another 2, or multiply by 2. We do have 3 2's, but we just need a 5. So we're going to need to multiply this number on top and bottom by 2 and 5, or 10. Then we're going to add 3 over 20. Let's break down 20 into 2 times 5. This way we can see which factors we're missing. So we know we have 2 2's, but we are missing 2 3's. So we go 3 times 3, or you could just multiply it by 9, because we have all the 2's and we have the 1 5. Now we're going to go ahead and multiply the top together. And then our denominator will be 180. So 17 times 10. So we're going to do this over here. So we have zeros. When you multiply anything by 0, then we move on. We have a 0 for our placeholder. 1 times 7 is 7. 1 times 1 is 1. And then we add, and we get 170. So our first number is 170 over 180. Plus 3 times 3 is 9 times 3 is 27. And then it's over 180. And then now we go ahead and add. So we have 170 plus 27. 0 plus 7 is 7. 7 plus 2 is 9. And then 1. So we have 197 over 180. And that would be our final solution.